All right.
Mr. Kiefer.
So yesterday, we stopped with, we're ready for 6C on review number 2. All right. Just giving us good review, making sure we're up to snuff with all of our problems. So we've got x cubed plus 3x squared plus 9x plus 14. Now, if you recall from yesterday, the first one, letter A, grouped. Letter B was just a quadratic, so we use the formula. Now, this one doesn't group, and it's not quadratic, so we're not using the formula. So what's your thought? How are we going to begin finding the zeros here? This is on the no calculator part of the test. What are you going to do? Find the PRRs. That's exactly right. So what are your possible rational roots? Factors of 14 over factors of 1. Easy peasy. Now we'll just start guessing. So one quick thing that you might notice, you see how all these are positive? Right? What kind of numbers do you think I should choose? If I want to end up with a 0, don't I need to get some negatives involved? So I'm not going to try any positives. So, I don't know, let's try -2. Remember, you're on your own when it comes to guessing, and so sometimes you'll guess it right off the bat, sometimes it'll take 2 or 3 times. Let's see what I did here. Oh, hey, that worked out, I think, didn't it? Okay, so what does that mean now? What does that mean? Oh, there she is.
Quadratic.
Well, it means one of my answers is -2. And I can find the others by dealing with this, which is a quadratic that does not factor. So I'm going to need to use my quadratic formula. So here we go. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So what have I got underneath that radical? 1 minus -27. Of course, I'll pull out the I. Root 27. Does that break down? Caleb, I made you cookies. 3 root 3. And there are the other 2 answers. So there are 3 answers to this problem. 3 answers. Here are 2 of them, and there is the other one. Okay? So in this exercise, yes, we heard it yesterday, but we have grouping, we have that possibility, and then we also have the guess and divide possibility. All right, number 7 says find the remainder. You do not want to divide this out, you guys. Why? Why do I not want to divide this problem? Too many zeros. That's x to the 50th. That's way too big. So what do I do instead? What is another option for me if I am interested in knowing the remainder? Plug it in. That's exactly right. So we think of this as a function, and we plug in the number we would have put in the box. So what number would I put in the box? 1. So I just plug in 1. So that's going to be 3 minus 3 plus 10 minus 3. It looks like the remainder is 7 if I did my arithmetic correctly. Just putting in 1s for all of the x's. 8 is a sketch, but it's an easy sketch because the thing's already factored for you. That's a game changer, right? That saves lots of time. So, since it's already factored, I know I'm gonna have an x-intercept at -1, 0. And remember, we are labeling these points. 3, 0. And -5, 0. Now those are the only x-intercepts. I know that there is a 1/2 out in front, but it does not have an x. So it is that n number that we find sometimes. We don't grab it itself. It impacts the graph, but we don't grab it. All right, so I got my dots up here. How many x's does this problem have altogether? 4. Now, you need to know that. That determines where you start your picture. Because if your degree is odd, you start down here. If your degree is even, you start up here. This is like x cubed, this is x squared, even, odd, right? So this is an even number of x's, x to the 4th. So it starts up here. The only reason that it would ever not start here is what?
If there's a negative.
If the 1/2 was a -1/2, then it would get flipped over. But that 1/2 is positive. So it's going to start up here. And every time you get to the axis, one of your dots there on the axis, every time you hit that, you have to ask yourself, do I go through it, do I bounce off of it? Well, that root came from the x plus 5 factor, which isn't squared. So what am I going to do? Go right through it. And you come down and you got to connect. You have to connect to the next dot. They always connect. Now, that one came from the x plus 1 factor, which also isn't squared. So we'll come up and connect to this one. But that dot came from a squared factor. Look at it, see it? Squared. So that means it's going to bounce off.
I have a question for you. I was just doing this yesterday and I was looking at the answer key. It says like 0, comma 22.5.
Oh, I just grabbed the y-intercept. You don't have to plot it.
Oh, okay.
I just did. That's the y-intercept. We'll be graphing all the intercepts in the next key now. So just getting a head start there. Thank you for looking at it yesterday. Okay, number 9. Write an equation for a quadratic function. Oh gosh, I think we did this yesterday, but let's do it again. Vertex -2, 1, and containing the point 4, 6. This is a quadratic. Okay? Do not find slope. When do we find slope? One time. Linear, 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 line, 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 line. That's it. No slope other than lines, okay? So, how do I start building this equation?
It's y equals x plus 2 parentheses y plus 1.
Perfect. Stop right there. He's right on target. Look at that vertex and understand that your parabola, quadratic parabola, has been shifted off the origin and it's moved 2 units left and 1 unit up. That's what this means. So you take your x squared equation and you move it 2 units left and 1 unit up. That's old news. We know how to do that. Now we find this coefficient that will guarantee we go through this point. Because there are lots of parabolas with this vertex. We want the one that's just the right size to go through this point. So what do? Plug it in. So 6 equals n times 4 plus 2 squared plus 1. And I keep saying this, but it is so tempting to not put these in the right spot. This is x, this is y. Make sure you're putting them in the right spot in the equation. So, 4 plus 2 is 6, squared is 36. This is 36n. Do not add 1. It's 36n plus 1. So then the 5 comes over, and we divide. So in the answer blank, this is what you write. The answer isn't 536. The answer is the equation. Perfect. We did that yesterday. You okay with that? All right. Now we have an object thrown vertically. I think we did one of these yesterday too. Its height above the ground is given by this equation. Okay, so when you look at this equation, you notice that it is a parabola opening down. I hope you noticed that. Okay, and we want to know the same three questions we wanted to know yesterday. When does it reach its maximum height? What is its maximum height? When does the ball hit the ground? Okay, so you got a quadratic with a negative coefficient. It's this picture, right? So any question that involves maximum is talking about the vertex. Make sense? So how do we find the vertex? Easy way, quick way. Negative b over 2a. So x equals negative b. Oh, watch it now. These are backwards. So b is 40, a is negative 8. Everybody catch that? That equation's written backwards. So negative b over 2a. What is that? 5 halves? Is that right? So that's what? What is the 5 halves? That's the x coordinate of my vertex, right? Now I can find the y by plugging in. Remember that 5 halves squared, 5 halves squared is 25 fourths. So this is 100, and this is 50. I got 50. Is that right? So let's answer the question. When does it reach its maximum height? 5 halves seconds. So A is 5 halves seconds. I'll do a better job on the test and actually put units in here. Let's say seconds. And then how high does it go? That will be 50 feet. Now, when does it hit the ground? Kids, when it hits the ground has nothing to do with that, right? When it hits the ground is here. So how do we find where it equals 0? Isn't that what we're looking for, the zeros? So don't we just set that thing equal to 0 and solve it? So it is a quadratic, so if you wanted to, you could use the formula. But like yesterday, this one does factor. You can take out an 8t. Makes sense. I'm going to get 2 answers. One of them is 0. That's when the ball starts. That's the beginning, and then it goes up, it comes back down. When does it hit the ground then? 5 seconds, right? 5 seconds. The volume of a gas varies inversely with the pressure. All right, stop right there. Volume varies inversely with pressure. There are 2 kinds of variation that we have studied. One is direct, one is inverse. The general equations, direct is y equals k times x, inverse is y equals k over x. So that's your background information. That's what's stored up here. So when it says write an equation for the relationship, and it varies inversely, I'm going to write an equation using that model. Since my things are volume and pressure, I'll say volume equals K over P. And then find the constant of variation, that's K, this is called the constant of variation, when the volume is 100 and the pressure is 10. Easy. What's K? 1,000. Yeah. Period. Easy, easy, easy. But you have to know your setup there. All right, now we're switching over to the calculator, so I need everybody to get your calculator out. Everybody's getting out a functioning calculator. Huh?
Whenever we get like, I was trying to figure out whether like going up and up, you know?
Uh-huh.
Like, how do we know it's 4x?
And then one of them squared. So we have an x, an x squared, and an x. That's 4. Okay. All right, so I need to see a functioning calculator on everybody's desk. It should be open, and you should be pressing buttons with us, not sitting and staring at me pressing buttons. That does not get us very far. We all have a functioning calculator. Oh my gosh, we do. Impressive. All right, here we go. Connor forgot 2 apostrophes, so his wonderfully kind teacher deducted 12 points. He forgot 3, lost 38, forgot 4. All right, so can you feel as you're reading this problem, you've got a set of data points here, that 2 goes with 12, if we're talking about apostrophes and points. And then 3 was 38, 4 was 82, 7 was 382. All right. Using the cubic regression feature of your calculator, write an equation to describe this, and then figure out if he forgets 5 apostrophes, how many points he will lose. All right, so you know what to do. We're going to go to Stat and Edit. Now, if you have numbers already in there, you can type right over them. This is going to be L1, so 2, 3, 4, 7. And then L2 will be 12, 38, and so on. All right, you don't need to graph this because you're told exactly what kind of curve you're fitting here. It says cubic, right? So go back to Stat, over to Calc, and down to Cubic Regression. Now I want to talk about B. What does your B say? Okay, that, I think we talked about this before, but let's talk about it for sure today. That means 0. There is a little bit of round off error in the calculator because he doesn't do things like with the actual numbers. He does everything logarithmically. So he's using logarithms to do everything. So because of that, sometimes we get a teeny bit of round off error. So that is the same as 0, right? If you take something to the negative 11th power, doesn't 10 to the negative 11th, isn't that really small? Yeah. So we're going to interpret that as 0. When that pops up on our calculator, we think of it as 0. Everybody hear that? Okay, don't come running up to me on a test or quiz and say, "Wah." No. If it's e to the negative something, big power, it is 0. All right, so what's my equation? Y equals 1x cubed, no x squared, 7x minus 10. No x squared because the b, look at the equation on the calculator, the b is what goes with x squared, and we just agreed b was 0. There's your equation. So how are you going to find out how many points he loses if he does 5 apostrophes? You're just going to plug in 5. And I think it's 150. Is that right? Yeah, I hear talking. Do I have a mistake up here? Somebody have a question? What's the plan? What's going on? And that would be 150 points, right?
Are you supposed to have the plot on for it?
Don't need it.
Will it, like, say if you do put the plot on it, change it?
The old calculators won't work if you do.
Okay.
All right, CJ's company determines that the supply function for its latest musical device is this, and the demand function is this, where P is the price of each device. Find the price where the supply will equal the demand. So pretty much the problem says 5 plus 0.001 P squared has to equal 10 minus 0.02 P cubed. Would you agree with that? I mean, they tell you that supply equals demand. Econ students, what do we call that point right there? Equilibrium? Oh my gosh, you forgot? You took econ, what? Last year? When did I take econ? Oh, 40, I don't know how many years ago. Equilibrium point. All right, how do we find that? Now remember, you have a calculator. You are supposed to be using your calculator. So what I would do, you really have two main choices here. You could move everything over to one side of the equation, get it set equal to 0, and then when you graph your one equation, what would you be looking for? These points right here, right? If you set it equal to 0. You could also leave it just like it is, graph this as one equation, graph this as the other equation, and then you have, and yeah, I'm totally making this up, but you have two equations, and you would be looking for where they cross, right? So it doesn't really matter which way you do it. It's the same number of button pushings, because you're either going to do second calc 0 or you're going to do second calc intersect. All right, so let's do it. Everybody types them in. However you want to do it.
Can you use the P's out of the X's? This one?
Yeah, these are X's.
Okay.
You're putting them as X's in the calculator. And you're probably going to need to do some window adjusting here. Now, to help you figure this out, keep in mind, if you're having trouble with your window, keep in mind, what does your X or your P represent? Price. Have you ever gone to the store and had a price be negative? No. So X min should definitely be 0, right? So start with that. If you're having trouble with your window, start with that idea. I set them both, I left both equations. I typed in each equation, and I used the window 0 to 10 and 0 to 10, where the X's and the Y's, and I got a nice picture. got them crossing here, so I'm gonna figure out where that is. Doing my intersect. Okay, so my point was 6.28, comma, 5.04. Of those two, which one is the one I'm gonna write down in the answer blank?
6.28.
6.28. So the price is $6.28. All right. I've got 60. Okay, X is the price, and that's the X coordinate. Right? Yep. All right, so now let's see. We got 60 pounds of paper, selling granola, price. All right, so this is one of those problems where income initially for me is 60 pounds and I'm selling them at $2 a pound. So right now, my income would be $120. Agreed? But things are changing. What's happening?
You add 10 pounds a day.
Every day I add 10 more pounds. So if I let X be the number of days that I wait, then how many I'm selling will be 60 plus 10X. $10 for every X getting added on. And then I'm losing, every X though is gonna lose 25 cents. Please don't put 25, it's 0.25, right? And I want to maximize this, which means I want to find the vertex. Now, I don't need a calculator, and honestly, for some of you, using the calculator is going to take longer. You may need the calculator to help you with the arithmetic, but isn't this going to be an x squared?
Mm-hmm.
So to find the vertex, I can just do negative b over 2a. That's what I'm looking for. But I do need to FOIL this out, so you may need some help with that. So 120 minus 15 plus 20 minus 2.5. All right. All right, so I did not use my calculator. I hope that I multiplied correctly. And negative b over 2a. I got 1. Any confirmation from that? Okay. Now, one what? What is that? $1? 1 pound? What is that? That's 1 day. That's 1 day because I defined my variable. X was the number of days. So what does the question say? How many days should she wait? The answer is 1 day. Now, be careful because the question might say, how much should she charge? Well, I'm charging $2 right now. I'm going to wait 1 day. So the price I'll charge is $1.75. What is that? Does anyone know? Is that one of your pieces of equipment? Is it one of those things right there?
I think it came from out there.
It did?
I think so.
Okay. All right. All right. So one other question might be, how many pounds will she have to sell? Well, remember, I have 60 right now, but I'm gonna wait a day, so I'll actually be selling 70 pounds. Make sure when you ultimately answer the question that you're answering the question. This one was how many days? 1 day. All right, finally, Taylor lives in the house below. She wants to enclose 2 sides of the yard. So the total area of the house and fenced in the yard is this. Find x between the distance between the house and the fence. Okay, so this is a little bit different than the other one we did because we're just putting the fence on a couple of sides. But I think it's going to be about the same. So here's the house, which is 30 by 60, and then you're adding this on. Okay, so this is x and this is x. And the total area of the whole shebang is 10384. Okay. What's this? 60 plus x. Perfect. It's 60 plus x. What's this? 30 plus x. And if I multiply those two together, shouldn't I get the whole area, 10,384? There's your equation. So 60 plus x times 30 plus x has to equal 10384. Now, oh shoot, I can erase the picture. If I FOIL this out, I'm going to have 1800 plus 90x plus x squared. Make sure that's right. So x squared plus 90x minus, I'm getting it set equal to 0. So 1800 minus 3584. Everything making sense so far? Now you have to solve this equation. So you've got a calculator, so you got like options. What kind of an equation is it? Quadratic. So you could use the quadratic formula, right? That would be an easy option. Remember, you have a calculator, so don't let the size of the numbers bother you. You could also graph it, right? And look for where it crosses the x-axis. I think I'm just going to go ahead and use the quadratic formula. Yeah, don't be scared of the big numbers. You just type them in. I got 58 for one answer. Oh, I think that is the answer. Because if I do the other one, won't it go negative? $58 seems awfully big. Anybody else get 58? Oh my gosh, don't just burn and copy down what I did. It could be wrong. Type that in. Did you get 58?
Yeah, 58. Yeah.
Thank you.
I got it really good.
Did you remember to take the square root? There should be another answer, but can everybody see why I'm not typing it in? It'll be negative 90 minus this. So that'll just be a negative answer, and I know X isn't gonna be negative, right? Because it represents that distance between the house and the fence. So 58 feet is my answer. All right, let's quickly, we got a little bit of time left. Let's look at review sheet 1. Well, it doesn't say 1 on it, but it's the other review that doesn't have a number on it. And skim on down through there. And tell me, and there's some on the back too, there's 15 problems. So tell me what we need to do, because we won't get this sheet done today. So of all those problems, what do we need to do to be ready for a test the next time we are together? Yep, so for number 2, it's moved 1 unit to the left, 9 units down, and it's going to be skinnier because it's rising twice as fast. Nobody sees anything on there that you might miss. So in other words, when I grade these papers, they're all going to be perfect.
I think a word problem would be the hardest for me.
Alright? Well, let's pick one and do it. So what word problem are we going to do? Let's pick one. And I'll hand back some papers while you're getting started on it, and then we'll all finish it together. So which one are we doing? Which word problem? 14? Alright, jump in. Let's do 14. See if you can get it started. I'll pass out a few more papers, and then I'll help if we get stuck. I'm not seeing a bunch of pencils moving on the paper. Are we all stuck? Do you not know what to do?
I think we're just looking at 2.3.
Okay. Well, let's get problem 14 done, and then we'll look at the homework that you might have a question about. I'm almost done with papers here. Alright, so let's see what's got everybody stumped. Number 14. Find the dimensions of the largest picture that can be framed by a blue and gold ribbon that's 124 centimeters long. So basically what we're saying is we have a rectangle and its perimeter has to be 124. So I'll call that X. I don't know what that is, but I know this is going to be 62 minus X. Now, how did I know that was going to be 62 minus X? Keep in mind the perimeter is 124. That means 2 lengths and 2 widths make 124. So what is 1 length and 1 width going to make? 62, right? If all the way around is 124, isn't half of it 62? So if that's X, that's 62 minus X. And I want to maximize the area, largest picture, that would be area. So the area is going to be X times 62 minus X, or negative X squared plus 62X. That is my equation if I do the distributive property. Negative X squared. Parabola opening down. I want the largest maximum vertex, negative b over 2a. Looks like X needs to be 31. And it says, what does it want to find the dimensions? So if that's 31, what's this? 31. Unit is centimeters. So what are the dimensions? 31 by 31. All right, let's do one more. Or more, I don't even know how much time we have left. What else do we need to do? That was apparently a good one, because nobody knew how to do it, so now we're ready. Let's get another one going. What else should we do? 12. Find the maximum volume of, oh, here we go. We've done this about a zillion times. Find the maximum volume of a box that is made from a paper that's 10 by 14 if equal squares are cut from each corner and the resulting flaps are folded up. Boys and girls, this is our box problem, isn't it? Yep. What is the formula or the equation that I'm going to use? Like here, I did length times width. What am I going to do here? Length times width times height. And if the paper is 10 by 14, what do those dimensions look like? 10 minus 2x, 14 minus 2x, and x. Because you got your paper, you're cutting an x off each end, right? That's minus 2 this way and minus 2 this way. Now, that one, I'm not going to do what I did here. This is very fast for me because it's a parabola and I can do negative b over 2a. This is not a parabola, is it? That's some cubic thing, right? So I'm going to graph that on my calculator. These are the calculator problems. I don't know if I denoted that or not, but it would be a calculator problem. So this one actually could be a no calculator problem. This one will have to be a calculator problem. So remember, your window is all messed up probably from the last problem you did. So you'll want to pay attention to that. But there's no magic calculator fairy sitting on your shoulder. You've got to be able to figure this stuff out. and look up here and see if that's what you got. Is that what you got, Ollie?
Yeah.
Okay, good. Now, make sure you answer the question. What am I supposed to be finding in this problem? Caleb, what am I supposed to be finding? The maximum volume. So now I need to pick a number. Which of these represents the volume? The Y does. So your answer would be 120.164 cubic inches. What's the 1.9 number? The size of the squares. Yeah, so, and it could say that. It could say find the size of the squares. But it says find the maximum volume. Alright? What else? Either side. Any of these problems. Three?
No, 3.
Yeah, number 3. Find the quotient and remainder. So I guess if it's asking me for a quotient and a remainder, it wants me to do what? Divide. And what I really just need to be on the lookout for, you've all done a ton of synthetic division, you're very good at it. You do have to pay attention though, because in the box, find the quotient and remainder. So in the box, there'll be a 2, agreed? But then these numbers, be careful. I'm going to have a 3, and then a 0, and then a 9, -8, and 1. Why do I have to put a 0 in there? Because there is a missing x cubed. Remember, if this is x to the 4th, you have to have x cubed, x squared, x a number. And then I'll just synthetically divide. I have no idea if I did that right or not. Let's see. Does that look okay? So if there's a quotient blank, you're going to write 3x cubed, down 1 power, plus 6x squared, plus 21x, plus 34. That's the quotient. And then the remainder is 69. If you're writing out the whole polynomial, you definitely have to put that over x minus 2. I don't care if you write 6, if it says what's the remainder, you can say 69, or you can say 69 over x minus 2. That's up to you. All right, Jacob, you okay with that?
Yeah.
Okay. All right. Anything else? All right. Yeah. Yep. Okay, what's the question? Oh, yeah, I have to look at it and see. So, which homework is this on? 2-5 homework. Oh yeah, you should be able to do this. So you've got -3, 0, -1, 0, and 2, 0. And we got okay. All right, so start with the intercepts, right? Because the intercepts give you the factors. So what do I know my factors are?
3,
x plus 3,
x plus 1,
x plus 1,
x minus 2.
x minus 2. So that's step 1. I'm starting with that. Now I need to look at my picture because there might be some powers on those factors. So I'm just going to start tracing over it. Oh, what happens right here? I bounce off. So that factor, which is this one right here, has a squared on it. This one, I just go right through, so no worries there. This one, I'm bouncing off, so that one is also going to have a squared on it. Right? You can tell that from the picture. You have to be able to see that in your picture. Now, there are zillions of polynomials that have that shape. I want the one particular one that goes through that point. Right? So I need to figure out what that leading coefficient is that's going to give me a y value of 3 when the x value is -4. So I'll do the arithmetic here. So -1 plus 3 is -1 squared is 1. -4 plus 1 is -3. -4 minus 2 is -6, squared is 36. So 3 equals n times, what is that, -108? -1/36 if I reduce my fraction. Now, am I supposed to multiply this out? No, so that's good news. That's good. That means I'm done, basically. Just make sure that you bring that down, and in the answer blank, you stick in your n value, and that is your equation. Okay? Easy. Easy, easy, easy. All right. That's it. Tomorrow, all right. But Thursday's D-Day.